Good evening, everyone. I'm Andrew Cody.
I'm Austin Bramley.
I'm Akash Kumar.
I'm Simeon McGraw.
I'm Andrew Valenci.
And as a team, we have Big Project One, which the focus of this project is for my team to be a cloud provider to do the implementation and deployment of a cloud computing infrastructure. The main goal is to set up the infrastructure by implementing the Zun container services to provide the default Openstack profile with the ability to manage the containers such as Docker and to be able to launch Docker container from the Openstack without the use of VM. All this is done through the use of various tools like PuTTY, PowerShell, MobiXterm, and services like Cloud Lab, Zun, etcd, and Courier. For providing with servers, with cloud servers, with Big Cloud Lab, because we thought that would be the best option to give us a smoother installation and to give the best controlling for the compute and the controller node. I'll hand it over to Andrew right now to talk more in detail about the rest of the services.
We picked Zun because it's an OpenStack container service. It provides OpenStack the ability to manage application containers such as Docker. Also, Zun provides API endpoints for OpenStack to integrate with other OpenStack services. etcd is a distributed, reliable key value store, which is simple, fast, and secure. It acts like a backend service discovery database. It is used for storing configuration, keeping track of service liveness, and other scenarios. Courier is a Docker network plugin that uses Neutron to provide networking services to Docker containers. Courier aims to be the integration bridge between containers, frameworks, networking models to OpenStack networking abstraction.
By choosing Zun, we were able to conclude that it would be an excellent tool that gives the OpenStack the ability to have the right communication capabilities. All the information of the installation, the manual installation of Zun, we got it from OpenStack Zun guidelines, and this actually helped us create our own automated bash script. The proper installation step-by-step of Zun and the automated bash script that we've created will be in our GitHub repository and in the README file of our GitHub, which will actually fully update it by the end of this project. Another thing to mention about Zun is they need to be installed in the controller and in the compute node. To talk more about those, I'll give it over to Austin, who will describe them in detail.
Okay, so Zun requires a minimum of 2 nodes to function, a controller and a compute node. The controller node runs the identity service, image service, and management portions of Zun. It also manages networking and the dashboard. The compute node runs the engine portion of Zun that operates containers. By default, Zun uses Docker as a container engine. The compute node also runs a networking service agent that connects containers to virtual networks and also provides firewalling services to instances. So now I'll hand it over to Akash to talk about installation.
Before we configure OpenStack, we need to have an OpenStack experiment set up. So I want to quickly show you how to create your own OpenStack profile and use it to launch an OpenStack experiment. First, go to the GitLab repo default OpenStack build. You can find that through this URL. Download all the contents of this repo to your local computer. Then upload all the contents of the repo to your own GitHub repo. Once you have done that, you get something that looks like this. Scroll down a bit and you'll see 2 Python files, one named osb.py and the other named profile.py. Copy everything in osb.py to profile.py. The reason you want to do that is because when you create a new OpenStack profile from a Git repo, CloudLab first looks at the profile.py file and begins execution from there. So you want to make sure all your starting code is in it. If you skip this step, you'll not be able to create your profile. Once you have done that, click the green clone or download button and copy the link to your Git repo. In Cloud Lab, click on Experiments and select Create Experiment Profile. Name your profile. Select Git repo and paste the link to your Git repo. Hit Confirm and then hit Create to create your profile. With your profile now ready, scroll all the way down to the bottom and instantiate the master to create your new OpenStack experiment. Now I will hand it over to Simeon to talk about the automation phase of the project.
All right. And so I'm going to go through the bash scripts that we have. Basically what we did was we got the installation instructions and configuration for the courier network stuff and for the Zun, and pasted it into the corresponding bash scripts and adjusted it to our needs. So for the courier stuff on the controller side, it was just a matter of creating the OpenStack user and then setting it as admin. For the compute nodes, it's a little bit more involved. You have to create the system user for the service. All of this right here is just the installation for courier itself, and then adding the configuration, generating the sample configuration, and then making our modifications as needed. After that, we just create the service for courier and enable and start it, and then restart Docker to update the changes. For the Zun, the controller node is a little bit more involved. We have to set up the database here. Then we can create the admin user in OpenStack itself. And then we have to register the endpoints for the Zun, for the Zun API. We also have to create the system user. And then again, all of this is just the download and installation of Zun onto the controller node. Now we have to generate the sample configuration and then insert all of our values into that, which is all this right here. After that, we have to populate the Zun database by running this command right here. And then it's, again, create the upstart scripts, start and enable both the Zun API and the Zun WS proxy. On the compute side, it's a fairly similar process. You create the user, you do the installations for Zun as well as the adapter for the container network interface here, the CNI. You generate the configurations and then insert our values into it. After the configuration values are added, we just have to, again, create the services, update the Docker service here, and add these services, and then enable and start them. That's essentially what we have for the automated scripts here. Obviously, the end goal is to have all of these scripts integrated into the profile for OpenStack. So the GitHub repository that Akash was showing us earlier, we essentially just need to put these in the right place. Essentially where I put them was right after the Nova configuration. And since we're running Zun alongside Nova, we're just putting it right after that. And then we have to update all the values to match the essentially all the variable names, just get them all matched together, and then it should start up just the same as everything else does. That is about it in terms of the automated scripts. I'm going to hand this over to Endry.
Cool. The main reason that we actually created automated bash is because the installation guideline of Zun published in Openstack actually led us in some error. And the first error that we actually faced was when we tried to generate a sample configuration file. And this is related to configuring the components in the controller node. The problem that we faced was that when we actually try to execute the commands for the Zun config generator config file, it was leading us in a wrong path, and with basically was being executed in the wrong path, in the wrong folder. With the help of DuckDuckGo, we realized the problem, and what we actually did is removed the folder and remove the config file and put it in the actual original folder, varlibzun. And from that point, the Zun configuration file executed perfectly. The second problem that we actually faced was when we tried to edit the etcd file for the etcd services. This needs to be set to the management IP address of the controller node so it can be able to access other nodes via the management network. Our problem is that we left the file as it was, as default. I'll just share my screen right now. So the etcd file actually comes at default, and in the beginning we executed as it was, and we changed the IP addresses for the initial cluster and the initial peer URLs and the client URLs. We set it to one of the IP addresses of the controller node, which was not the right IP address, and the one that we're actually facing was giving us the etcd services have failed and was not basically cooperating, until we realized that we needed to assign the main IP address of the controller node, and everything apparently executed perfectly, and the etcd services were enabled and running correctly. The main and the final issue that we are actually seeing right now is the main goal of this project, launching the Docker container. I will hand it over to Austin, who will provide with more detail of the final issue and the conclusion of our project.
Okay, thank you. Yeah, I'm going to talk about where we're at now and where we're planning to go from here. So at this point in our project, we're about 2 steps away from completion. The first thing that is prohibiting us from reaching our goal is our inability to successfully launch a container using our new app container service. So after installing all the prerequisites and Zun itself, we were able to verify that Zun was operational by typing the line OpenStack app container service list. And let me show you that. So you can see here, if we run that line, we can see that our compute node is up and running. So the next step, after verifying that it's operational, is to launch a container, in our case, a Docker container. But when we attempt to launch the container on the compute or on the controller node, we receive an internal server 500 error, which you can see right here. And above, you can see containers that we have tried to launch that were unsuccessful. So after some troubleshooting, we were able to see that the problem is most likely caused by our Keystone authorization. authentication, sorry, that we set up earlier on in the project. So we were able to find that out by running the journal after trying to launch a container. And you can see here that we're receiving an exception with our Keystone authentication. So we're currently in the process of trying to identify the specific problem and to fix it. And so once we fix that, the last step is to integrate the Zun UI into the Horizon dashboard. The Horizon dashboard is the one we all know. I'll show you it here. The one that looks like this that we've been using in class. So once we fix our final error, the Zun UI is provided by Zun along with documentation on how to implement it. So we'll implement that UI into this dashboard, and we should be able to launch a Docker container directly through the OpenStack dashboard, and our project should be complete. And that's all I have. So does anybody else have any final words?
Nope, that's it. Thank you all.
All right, thank you.